Welcome to the first of a series of videos to show you how to use WebMO to complete the calculations for Chem 344. Our first video will work through the exercises uh, starting with the conformations of butane. First we'll log into WebMO, which brings us our job manager panel. By creating a new job, we can make butane in a nice little drawing utility. Java will load. It's default to carbon, so clicking on the screen will produce a carbon. You can click and drag to make the rest of the carbons in the chain, and there we have all four. Using the cleanup tool, we can click on either comprehensive idealized or comprehensive mechanics and get about the same result, where it will put in the hydrogens for us and get it to a reasonably good geometry to start the calculation. The lab manual suggests a comprehensive mechanics, which I will do. Next, if you notice, it says it has a C2H symmetry with a red icon, which means the molecule isn't symmetrized. By symmetrizing it, it'll speed the calculation along quite a bit, so I'm going to hit that button. It turns black to say that, yes, the computer will now recognize that it's a symmetric molecule. The next part we need to do is set up the scan for the dihedral, and we can do that under Tools and Edit Z Matrix. If you notice, all of the atoms are listed on the left side, carbon 1 through hydrogen 8. And if you read through this, the first column is the distances between them, and then some angles, and the final bit is the dihedral. The thing that we're interested in editing is the first dihedral angle here, which is currently set to 180 degrees between carbons 4, 3, 2, and 1. It's currently 180. I'm going to set that to scan. And then we will start our scan at the 180.0. We will stop it at 0.0. And let's go through, I'm guessing 18 steps might be fun. So when we hit that, it highlights these bonds in yellow saying that we've made it correctly. Then we can hit continue, which will allow us to select the queue we want to submit the job to. The best queue for us to use is the 344 queue. It's set aside just for users for Chem 344. Then we need to set up some stuff about our scan, and the lab manual suggests that we do a Hartree-Fock, which is the default, and the routine 631GD. The charge and multiplicity are already set correctly to 0 and multiplet. It's useful to give this job some sort of name that's going to make sense later. Hopefully you recognize that C4H10 is butane. In case you don't, we'll put a little butane on there. Normally this would be perfect and you could hit go, but there's actually a slight error that crept in the latest revision of Gaussian. So we need to make one quick little edit. So I'm going to go over to custom, or preview, and generate our input file. This is actually the text of what a normal input file looks like. The new version at Gaussian has trouble with this 180 degrees at the bottom, so I'm just going to delete that and press next, and the job will run perfectly as is at this point. So it asks if we want to submit an edited input file. It's a little bit nervous that we've made some changes, but everything should be just fine. The job will run, and then we can get our output in just a few seconds when it finishes.